In this video, we will talk about how to use synthetic substitution. So let's say we have the following polynomial. F of x is equal to 2x squared plus 5x minus 3. And let's say we want to find f of 2. Or in other words, if we plug in a 2 for x, what do we get? So one way to solve this problem is to use direct substitution, where we directly substitute a 2 in for x. So if we do that, we get 2 times 2 squared plus 5 times 2 minus 3. So we would get 2 squared is 4, 4 times 2 is 8, so we get 8 plus 5 times 2 is 10, minus 3. So we get 8 plus 10 is 18, minus 3 is 15. So that's one way to solve this problem. But another way to solve it is to use something known as synthetic substitution. And that's where we write this value, this 2, right here, and then we draw like this half box, and we write the coefficients of the polynomial, so the 2, the 5, and the negative 3, in order. So we say 2, 5, negative 3. And here's how synthetic substitution works. We take this first number and we bring it down so it lands right here. And then we do this number out here. So 2 times 2, that's 4. So we write the 4 right here in the next column, and then we add straight down. So 5 plus 4, that's 9. And then we do 2 times 9, which is 18. We put the 18 in the next column, and then we have negative 3 plus 18 is 15. The number that we get right here is our final answer. And you'll notice that this matches the answer that we got from direct substitution. Now you might be asking yourself, why would we ever use synthetic substitution instead of direct substitution? Well, usually synthetic substitution is better to use when you have a polynomial with really high exponents. So like in this polynomial, the highest exponent was a 2. But you can imagine if we had some polynomial where, let's say this was like a 6 or a 7, and we wanted to find, let's say like f of 3, 3 to the 7th or 3 to the 6th, that might not be immediately obvious to you off the top of your head. So in those scenarios, synthetic substitution is actually faster. So let's check out another example of how to use synthetic substitution. All right, let's say we have the polynomial f of x is equal to 2x to the 4th minus x to the 3rd plus 5x plus 3, and we want to find what is f of 3. So using synthetic substitution, remember this is the value that we place on the outside, so we'll say 3, and then we can write each of the coefficients from the polynomial. So we have a 2 and then a negative 1, and notice that there's no x squared value, so that means we need to put in a 0 as a placeholder. And then we have a 5 in front of the x, and then we have a 3. So we can use the same process as the previous example. Let's bring down the 2. We'll say 3 times 2, that's 6. We can write that right here. Negative 1 plus 6 is 5. 3 times 5 is 15. 0 plus 15 is 15. 3 times 15 is 45. 5 plus 45 is 50. 50 times 3 is 150. And then lastly, we have 3 plus 150 is 153. So that is the final answer. That is what f of 3 is equal to. So those were just a couple different examples of how you can use synthetic substitution.